Prachi, I can hear you.
Ma'am, actually, yesterday I didn't attend the session, so I don't know much about it.
Doesn't matter. You'll get enriched today. So we'll be talking further details of it. And our resource person, our Goku sir, is already with us. So we'll be going ahead with the talk regarding the same. Okay?
Okay, ma'am, thank you.
Okay.
Namaste, ma'am.
Namaste.
Ma'am, I would like to talk to sir,
Yes,
if I could.
yes, yes. Srihari, right?
Yes, ma'am.
Srihari, would you like to talk to sir?
Yes, ma'am, I do.
Please. Gopu sir, can we take some of the students for their
Yes.
queries with you? Yes,
Sure.
Srihari.
Namaste, sir.
Namaste.
Sir, you have been to Microsoft in USA and you have been
Yes.
holding an engineering degree. Sir,
I'm sorry. Come again.
you are also a holder of engineering degree, right?
Yes.
Sir, I would like to know that what inspired you to pursue this particular Indian mathematics and Indian astronomy, since you have been in one of the most developed nation, that means America. Then from where the science seems
Yeah.
to be.
So no, that happened more recently. It didn't happen when I was in Microsoft. I quit back 2000 itself. I came back,
Sir,
but 2000, yes, 2010 I heard a series of lectures on Sanskrit, and we have a group called Tamil Heritage Trust where we do heritage talks. So all the topics that were discussed were all literature, art, dance, culture, things like that. I said, why not science? Science is also heritage. So the founder who was in the discussion said, why don't you give a talk? And then he gave me a book and asked me to discuss. And so then I started studying this stuff. That's when I got interested.
sir, let me ask you one more question.
Yeah.
Sir, since you have been exposed to the American culture and the most developed science in the world, although, how can you compare that with Indian mathematics or Indian astronomy, which was used to
Different
be.
eras. I have not, so I was a very, I was just like a very low level, entry level software developer in Microsoft. So cutting edge science is software. Still a debate whether computer science is science or not, right? There are people who think it's engineering, some people who think science, some people who think it's just a variation of mathematics. Some people think it is linguistics also. It's just you're programming using languages to, so a bit of all of that. Mathematics, I'm not talking any cutting edge mathematics. This is very, my talk is not so much about the latest stuff, but as about ancient stuff on things which you don't know, which we should. I think we should.
Okay, sir. Thank you, sir. Thank you.
Sir, actually, I have small doubt. Can I ask her?
Yes. As long as your coordinators permit, I have no problem answering questions. Go ahead.
Please go ahead, Srihari.
And sir, can I continue?
Yes.
Sir, I have a small doubt that we have to submit that assignment which you have shared on my email also. So that assignment we have to fill by attending class or after attending the class.
Very well, sir. I think I'll take up this particular query.
Yeah.
Well, in fact, dear child, the assignment that is there, you just click on in the link. It will forward and you can submit it by tomorrow, but before 9:30.
You may.
Yes.
What?
The link will get closed by 9:30. So you take your time, attend all the sessions, and then take up the assignment. Okay? Okay.
Thank you, ma'am.
Oh,
Okay, so we
so that we start just on time, and by then most of the children would be able to join in, so that each one of them get enriched by the session.
Didi, I think now we have more number of participants. So if you think, then you may introduce Gopuji to all the participants again.
Okay. I'll take up the introduction first. Yes, I'll take up the introduction first. So, dear students, and of course all the participants, we are blessed to have with us our Gopu sir, of course, born and brought up in Madras mainly, obtained his bachelor's in engineering, in computer science, computer engineering from Madurai Kamraj University, and thereon pursued his MS in computer science from Texas A&M University in College Station, Texas, US. He then worked in the USA as a software engineer, mostly at Microsoft at Seattle. Of course, after some time, maybe the software industry and the pursuit for software learning seemed a little boring to sir. So he returned to India to pursue a career in writing and screenwriting. But his interest turned in other directions, primarily history and heritage, including the history of science and technology. His article on several topics have been published in national magazines like The Week, The New Indian Express, and Swaraj. Our professor is an organizer and volunteer for Tamil Heritage Trust for programs like its monthly lectures, annual Heritage Site seminars, lectures, and lecture kacheris, and how that is how to see a temple, and how SAM, that is how to see a museum, etc. In 2016, Ramu Endowments bestowed on Sir the Vedavali Memorial Heritage Award for Sir service.
In fact,
Science in Chennai and online as well. He conducts a course on Indian astronomy
targeted.
हेलो, ये आवाज दीदी की कट रही है, मनीषा दीदी की, आपको भी, मुझे भी कट रही है। एक्चुअली इनका कुछ नेटवर्क का इशू है, इनको स्क्रीन दिख नहीं रहा था। तो
ओके,
हाँ, तो वो फिर मुझसे कहीं कि इनका प्रोफाइल आप स्क्रीन पे लगा, मैंने कहा ऑलरेडी लगा हुआ है, यू मे इंट्रोड्यूस, तो कर दिया तुमने। इसके बाद गोपू जी अपना बताएंगे, जो बताना इंडियन कल्चर हिस्ट्री के बारे में जो करना हो करेंगे।
ओके भैया, आर यू एबल टू हियर मी?
उनको शेयर करना।
एम आई ऑडिबल टू एवरीवन?
जी मनीषा दी, आपकी आवाज आ रही है।
ओके, गुड इनफ। सो have you all I mean, I hope everybody has heard of what I was speaking, Mamta Didi?
Somewhere you were missing a few sentences, but I think it's okay.
Okay, shall I repeat the same again? I'll do the needful again, because maybe there's some kind of a network issue. So I'll just go through for the benefit of the children. I'll just go through the same again. So Gopu sir, as I said, has been born and brought up in Madras, obtained BE degree from Madurai Kamraj University, and MS in computer science from Texas A&M University in College Station, Texas, US. Sir worked in US as software engineer, mostly at Microsoft in Seattle. Of course, later on, probably the Indian culture and heritage interested Sir more. So Sir returned to India and pursued his career in writing and screenwriting. But his interest basically and primarily is more on heritage and including history and science and technology and study of that, the ancient Indian culture. His articles on several topics have been published in national magazines like The Week, the New Indian Express, and Swaraj. Gopu sir is an organizer and volunteer for Tamil Heritage Trust for programs like monthly lectures, annual heritage site seminars, lectures, kacheris, etc. And how to see a temple and how to see a museum, and that's quite interesting. In fact, even I would like to know exactly how to see a temple and how to see a museum. In 2016, Ramu Endowment bestowed uh, on Sir Vedavali Memorial Heritage Award for services to culture. Gopu sir is also the co-founder of Vardamihir Science Forum, which conducts monthly lectures in science in Chennai and online as well. He conducts a course on Indian astronomy and mathematics targeted at the general public and not only the professional astronomers or mathematicians. So he's doing a lot of work in this regard. And I mean, the, the lecture series that is going on, it's really of interest to me that hardcore engineers who've served all across the globe are doing so much of work towards the Indian knowledge system. A very warm welcome to you, sir. And I'm sure all the students would like to listen to you. So I put my voice to rest and hand over the forum to you, sir. A very warm welcome to you.
Thank you. Um, shall I share my presentation and start?
Yes.
Okay. Is it visible? Okay, it's taking time.
It's visible now, sir.
Okay. Okay. So I've tentatively, or named my talk Tamasoma Jyotisham Gamaya, a little bit of a pun on the phrase, the mantra, Tamasoma Jyotir Gamaya. And I titled the talk, The Men Who Knew Zero to Infinity. I gave this talk last year at Indian Science. I write a lot about some of these several subjects, including astronomy, at my blog, and that's my address, and you can see that later if you want to do some reference kind of things. Okay, I'll start with some Sanskrit verses. First I have to tell you that while I'm talking about mathematics and astronomy here today, and in Sanskrit, I don't know Sanskrit. I don't have a degree in Sanskrit. I have not learned it. I only know bits and pieces, quotes from the text that I've read. I'm not an astronomer. I am a computer engineering science graduate, not an astronomer. I'm not a mathematician. So with all those cautions, I'm only an amateur. I only have an amateur interest in this. I'm not even a professional historian. So I have to warn you of all of that. But with that, I'll start with a couple of things that you're probably familiar with. Even those who are not familiar with, people who are not expert in Sanskrit language or may not have learned it, will know some stuff, some of these things. You have heard of it surely. So I'll start with some of these. This first sloka, so if you can read Devanagari, you can read right there. Otherwise, there is the transliteration in English Roman script here. Saraswati Namastubhyam Varade Kamarupini Vidyarambam. Probably some teacher has started a session or class with this particular prayer, and so I am sure it's a salutation to Saraswati. Very often invoked Saraswati Puja, Vijayadashmi, just cross that and all that. So I am sure you're familiar with that. The second one also you're probably familiar with. Shuklam Bradaram Vishnum Shashivarnam Chaturbhujam. I usually have this as an interactive session in a small class, about 25-30 people. And I ask them who this is. Who is this a prayer to? Who is Chaturbhuja? Chaturbhujam, it's a salutations to Chaturbhujam. Prasannapadanam Dhyayet Sarva Vignopashantaye. And I have some answers generally. Vishnu is Chaturbhuja. So some people say because of Vigna, this is a prayer to Vinayaka. But this is a prayer to Vishnu. He is called Chaturbhuja among several attributes because he has 4 arms, right? 4 arms. And so with these familiar shlokas, I will introduce you to your third one. You have probably not heard this. Tribhujasya Palashariram Samadala Koti Bhujardha Samvargaha. I don't want, like I said, I usually have an interactive session, so I expect a response. I ask them who is Tribhuja. If Chaturbhuja is Vishnu, who is Tribhuja? Anybody heard of it? And look at this, very strange. You can probably recognize these words. Tribhuja, Phala Shariram. Phala is like fruit, Shariram is like body. Samadala Koti Bhujardham Samvarga. Does that make any sense? Have you heard a prayer like this? Just write on a piece of paper just so you can cross check whom you think, because I'll ask a couple of interactive questions. You just write it on a piece of paper, and when I give the answer, cross check to see if it is right. This is not a test. This is just kind of my way of introducing you to concepts that you may not have heard of. That's all. So who is this Tribhuja? We have never heard of a 3-armed god, have we? All right. Yes. Somebody
Brahma.
wants to say something?
Brahma.
Brahma has
Yes.
4 heads, not 3 arms. He is shown, the 3 heads are shown, but he has 4 heads, Chaturmukha, and he definitely does not have 3 arms. He has 4 arms also. Okay. It's all right. I'll explain. I'll give a translation word by word. Let me give you the meaning of this shloka first, then I'll tell you what the words mean. The meaning of this shloka is this: a triangle's area is a result of multiplying the perpendicular by half the side. Tribhuja is a technical term for 3-sided object. Bhuja is arm. Tribhuja is 3-armed. In English, we describe, or Latin, Greek, we have used the word triangle. But the Sanskrit word for triangle is actually Tribhuja. Shariram is a technical word for area. Phala means either fruit or result. And in this particular case means its result. That is the product of this multiplication, right? Samvarga is the technical word for multiplication. Bhuja, Ardha is half side. Ardha, is half in Sanskrit. Bhuja is side, as I just told you. And Samadala Koti is another technical word. Perpendicular is not an English word, it's a Greek word. Like that, Koti or Samadala Koti is a word for perpendicular. So the triangle's area is a result of perpendicular multiplied by half the side. This is the meaning of this shloka. If you have not heard of this, if you have not encountered this kind of thing before, you should now revise your idea of what is Sanskrit, what is mathematics, and why have I never heard of this before. Right? All right. This is actually a shloka in Aryabhata's Aryabhatiyam. This is 1500 years old. Aryabhata wrote this book in our modern Christian calendar. It was the year 499. 500, considered roughly 500 AD. So 1520 years ago, Aryabhata wrote this. He didn't discover the formula for area of a triangle, but he merely stated it. He hasn't stated who discovered it before him or any such thing. Okay, this is one of the shlokas. Why not simply say, why should you go to a complicated way of saying it like using a Sanskrit shloka? Why not simply, we learn mathematics only with formulae like this, no? We use variables and stuff. Why not simply say area equal to half height into b? You can, of course, instead of using English letters, you could have used Sanskrit letters, but why not just say this? One, that is not, remember that the area of a triangle is a geometric problem, and this is algebraic notation. This is not a geometric notation. Algebra was called several things, including Bija Ganita in Indian terminology. And algebra really got invented around Aryabhatta's time. It is not clear, it's not absolutely clear if Aryabhatta invented it or there was some seeds of algebra before him also. But it started developing around that period. It continued on from that period towards the next century or so. Another 120 years later, a mathematician called Brahmagupta came along and wrote an entire chapter called Bijaganita. After that, others later, in fact, one of the 4 books of Bhaskara is called Bijaganitam. Bijaganitam became the standard term for algebra after that. So algebra kind of became invented only around this point, and they were not using this kind of notation at that point. Okay. And then from India, algebra went to Baghdad, to the Caliphate of Al-Mamun, who invited books from all over the world. And one of the books that went to Baghdad was Aryabhattiyam, that was translated as a businessman, an Italian businessman called Leonardo Fibonacci, who went to Baghdad, studied this book, copied it, translated it, and took algebra, zero, and Indian numerals to Europe. And that's how algebra traveled to Europe. But we use the word algebra, which is an Arabic word today, which then was adopted by Europeans and brought to India by Englishmen. And you don't use the word Bijaganita in our studies, you all use the word algebra. Okay. Another small history aspect. So that formula has a multiplication sign and equal to sign. Then we use all this plus sign, minus sign, all that, right? We use this standard. But these signs didn't exist always. They were all invented at different times. In fact, the signs that were basic arithmetic operations that use plus and minus were invented only in 1489, 250 years after Leonardo Fibonacci, by a person called Johannes Widman in Germany. The plus, the minus, the signs were called meher and minus. That was the Latin names for them. And then later on, plus minus is what we use them. At that point, the equation, the equal to sign was not invented. That came another 70 years later. It was invented by a person called Robert Record. He used 2 parallel lines to designate equality. And after that only this cross for a multiplication sign was invented by a person called William Oughtred, as also Englishman. And then this division sign was invented by a person called Johann Rahn in Germany. This happened all much later, right? So you're seeing this most familiar 5 arithmetic symbols, plus, minus, multiplication, division, and the equal to sign. 5 of the things that we learned very early. They are all much more recent than Aryabhatta or Leonardo Fibonacci. It's very strange, no? We don't study the history of science at all. We only study science or study mathematics. All history we study is either political, sometimes it's literary. We never study the history of science. And the history of mathematics and some of these other sciences is very interesting. So this is one of those strange occurrences where the most basic arithmetic symbols that we use today actually are fairly recent inventions, and much more sophisticated math came a lot before that. Okay. For example, this particular formula, right? You are familiar with this. Square on the hypotenuse is the sum of the square of the other 2 sides. So let's assume Pythagoras said it, we know that. But what Pythagoras said, he also didn't say it algebraically. He said it geometrically. He said the square on the side of the hypotenuse, that is the square, is equal to the sum of the squares on the other 2 sides. He didn't say off. He didn't give it as a squared is equal to b squared plus c squared. He gave it as a statement also. Because he also didn't have algebraic notation in his time. Pythagoras in the 5th century, which is 1000 years before Aryabhatta. Right? So there is a history to the development of mathematics that we are generally unaware of, and this is one of those. This is one other question that I like asking people about in an interactive session, which I won't. Again, you can write down the answers here if you would like, just as a cross check. If I asked if I can go to some 7th standard, 8th standard, most of you are college students and graduates and teachers and so on. I can go to 7th or 8th standard student and ask anywhere in the world, what did this? Surely they have heard of all these people. What did Pythagoras invent? They will tell you. Copernicus, what does he discover or invent? They'll tell you. Isaac Newton, James Watt, Edison, Charles Darwin, Mendeleev, right? Just write it down what this thing, major inventions, they have all done multiple things. You just write it down as a kind of a check to yourself. And now I will give you the answer, some answers. Pythagoras is famous for Pythagoras theorem, but of course he did a lot more math. It is just the most famous theorem is Pythagoras theorem. Copernicus is famous for heliocentric theory. Isaac Newton for gravity, the 3 laws of motion, calculus, a bunch of minor things that we'll ignore for now. Charles Darwin for the theory of what's called theory of natural selection. We call it evolution as shorthand, but he gave a particular theory for evolution called natural selection. And it's one of the contributions. He made a bunch of other researches also, which are much more specific, very, very specialized fields. This is a very general one for biology. It's his most famous contribution. Mendeleev gave us the first periodic table, of course, based on atomic weights, and then we use later different periodic table based on atomic numbers today. So almost any 8th standard student will tell you, any worldwide, they will study all of this. They have learned, at least heard of all of this. Now let me twist it around. We asked you and say, what did these Indians discover? What did Aryabhatta discover? Varahamihira, Brahmagupta, Madhava, Nilakanta Somayaji. Chances are you've heard of Aryabhatta and Varahamihira. But have you even heard of the other people? Brahmagupta, Madhava, Nilakanta Somayaji? Just think about it for a little bit.
Okay, would the children like to answer? Some of them have the mic.
Sure.
Manoj, would you like to answer? Or Parvati? Priyanka? Dhanush? Komal? Okay, so many children have the mic. I just hope after lunch they are not dozing off.
I only know Aryabhatta. I don't know anything
Okay,
else.
good.
Yeah, ma'am. Same here. We only know Aryabhatta and Varahamihira. And other none, we have no idea about that.
Yeah, we
You
don't
know
know the
what
rest three.
discovered or invented?
Aryabhatta invented zero.
Yes, ma'am.
The number zero.
Varahamihira about reflection.
Okay, so only thing we know about, so think about that. So only person you have heard here is Aryabhatta. Some people have heard of Varahamihira.
Aryabhatta and Varahamihira.
And people think he discovered zero or invented zero. Think about that. We make a philosophical point.
Pythagoras.
All these Western scientists are given on the left in white font, and in the right I have given Indian. You have not even heard of them. So if you said you never heard of, if you are a college student, forget college student, even high school student, and you didn't know these people, you don't have to be engineering person. You just have to be high school student. Like, I don't know, 800 million people in India, 600 million people in India. If you don't know the people on the left, you would be called scientifically illiterate. But if you don't know, even if you're a college graduate, if you know mathematics or even if you know engineering, and I assure you, 15 years back, I would not have been able to answer these questions myself. I would have known, I knew 15 years back all the people on the left. And I've heard of Aryabhatta, Varahamihira, Brahmagupta, and Madhava then, but I never heard of Nilakanta Somayaji. But ignorance of the people, Indians, and what they discovered is considered normal. Why? Can you imagine a European not knowing any of these on the people on the left? And we Indians don't know. Just a philosophical question. Okay. Dia doesn't want to know. Sorry. I had to put that in, right? So, okay, just for a bit of a relief. Okay, the most popular answer is that Aryabhatta discovered zero. No, he didn't.
Yes, sir. And I think Varahamihira discovered gravity somewhat.
That did not discover gravity.
Okay, sir.
Aryabhatta did not discover zero. First, get that clear. He did not discover the place value system. He did not discover the zero. Zero is at least 700 years older than Aryabhatta.
Brahmagupta gives rules to zero.
Brahmagupta gave arithmetic rules for zero. Correct. Addition, multiplication by zero. He gave rules for addition, subtraction, multiplication, division by 0, he gave. And then Bhaskara later corrected them. Okay, for division by 0. By 0, they were struggling. But that's good. That's a good one. That's a good answer. Most people have never heard of Brahmagupta. I didn't know much about Brahmagupta myself. And the place value, so Aryabhatta, the one thing you think you know, that 0 was discovered by Aryabhatta itself is wrong, because it's at least 700 years old. And the place value system that Indians are proud of, it's at least 500 years, probably 500 years older than Aryabhatta. No Indian ever discovered gravity or the heliocentric theory, except one person. Nilakanta Somayaji actually came up with a quasi-heliocentric theory. And so only Copernicus really came up with a heliocentric theory. India had a quasi-heliocentric theory, which I won't discuss today. All right. So just to think about it. Oh, what is astronomy? Because I want to make a clear distinction between astronomy and astrology. In India, the same Sanskrit, the same word is used for both. Jyotisham, right? Jyotisha, Jyotish in Hindi. Astronomy, as it is today used by Westerners or in reference to the English language, means study of the celestial objects. So planets, stars, orbits, eclipses, rising, settings, and then distant objects like galaxies and quasars and constant, all these kinds of things, right? All these comets and all. And astronomy is in tradition was used to calculate the time of the day, the days in the year, seasons and all that, and compute the clock, compute the calendar. That is what the practical function of astronomy was, to set the clock and kind of create a calendar. That was the practical use of astronomy. Astrology is the study of what will happen to your when you will get married, when you will get a job, whether your business, when your business should start, whether you will win an election or not, all kinds of. This is astrology. I am not going to be talking about astrology. I am only talking about astronomy. In fact, in all the great Siddhantas that the Indian astronomers have written, except Varahamihira and a couple of others before him called Garga and Parashara, none of them have touched astrology. They all dealt only with astronomy, study of celestial objects, mathematics, and so on and so forth. Why astronomy? In fact, the oldest book tells you what it is. It says astronomy, Jyotisham, is Kala Vidhana Shastram. It is the science of determining time. By astronomy, you can understand Kala, Dik, Desha Jnana. Kala is time, Dik is direction, and Desha Jnana is geography. So both celestial geography and you can determine longitude, latitude, and all that, studying astronomy and get a sense of position based on that. So that is what it says. And this has been repeated in several texts, that it is Kala, Dik, Desha Jnana. Aryabhatta described in his book, it is the shortest of the astronomical works, the great Siddhantas, has 3 chapters. One is Ganitam, the other is Kalakriya, or the determination of time, and the third is Gola, or the study of the celestial sphere. So Ganitam is mathematics, and all the way from way before Aryabhatta, long before Aryabhatta, mathematics was studied as a subject, subcategory of astronomy for thousands of years, 2000 plus years. India, mathematics was studied as a subcategory inside astronomy. That is why I am linking astronomy and mathematics in this lecture. Though the bulk is supposed to be mathematics, it came from astronomy. That is where I am going. Okay. And this is the only other area, and literally to do this. So why did this is Kala Vidhana Shastram? Because Tasmadidam Kala Vidhana Shastram. So says one of the books, Vedanga Jyotisha says, so whoever knows Jyotisha, whoever knows astronomy, knows Vedas, knows time. It's important because the rishis prescribed the correct time to perform all the yajnas and certain auspicious things. And so to do these things, astronomy was studied to calculate the time of the day, time of the year, day of the month, which part of the month, which ritu, which season, so on, all that. And the only other field where the ancients also used mathematics, which is not part of astronomy, was something called kalpa. and in one that kalpa in something called Shulba Sutra, the science of rope, using ropes to determine the geometrical designs for all these unusual fire altars. Notice that the square altar you formally this is called Vedi or Yajna Pitam. This you are probably familiar with, but they also had other ones like semicircular, octagonal, circular, triangle, this Garuda shaped thing with multiple bricks. So for this you had to calculate how many square bricks, how many trapezoidal bricks, and how many rectangular, how many triangular bricks you needed. There is exact calculations in the Shulba Sutras that told you. You are supposed to construct all these altars of equal area. Don't ask me why. A square Vedi, semicircular Vedi, octagonal, triangular are all supposed to be of equal area. So once you built a square one of particular size, you had to build up the equal area, and the Shulba Sutras told you how to do that. How to calculate circle, octagon of equal area, and so on. So this is two reasons why these subjects were studied. This is an easy question. Where does the sun rise? Any one person?
In the east.
East.
Sun rises in
Excellent.
the east.
Very good. Where does the sun set?
West.
Sun sets in the west.
Very good. West. When does the sun rise?
In the morning.
PM.
Yeah. So
Morning.
we set the day by sunrise, right? The day starts with sunrise, the day ends with sunset. So it's kind of a circular answer. But you are aware that sun rises at different times in different days and different geographies, right?
Right.
Yes, sir.
During the summer,
Yes,
it is a longer day. During the winter, is a shorter day. So it light rises later in the winter and earlier in the summer, and so on. At different angles also. The sun doesn't rise in true east. It grows from Tropic of Cancer to Tropic of Capricorn. So there is a different point at which it rises each day. Everybody knows this. Everybody who studied school, you have known this, right? Easy questions. So now we'll go to the trick question. Where does the moon rise?
From the west.
Okay. How many people think west? How many people think any other direction?
In the east.
East. So easy guesses. North, south, anybody?
South.
You can put it in a. So just note it down for your own benefit. Just write it somewhere. No. Just write it on a piece of paper. See, with sun, nobody had a question. Nobody had a doubt. With the moon, suddenly I ask your question east, west, and so on. Does the sun or the moon rise or appear to rise?
Appear to rise.
Why does it appear to rise?
Yes, sir, appear to rise.
Why does it appear to rise?
Because of
Rotation of
sun.
Rotation of the earth causes sun to rise in the sun to appear to rise in the east. Then rotation of the earth must do what to the moon? Must also appear to rise in the east, no? If sunrise is apparent because of the rotation of the earth, what about stars? Where do they rise? I see tremendous number of responses. I think lots of participants raising hands. Simple question, no?
Stars appear when the moon disappears. No, star appears when the sun disappears.
But if the sun, the earth
Sun is
rotates.
also a star.
Wait a second. The sun is just one more star. If the sun rises, stars must also rise. Stars must also set, and this all appearance is only apparent, right? Because of rotation.
Yes, sir.
You write down the answer and then verify when I give you the answer.
Okay,
just for your own satisfaction. Where does the moon set? Of course, they are twin questions. The moon rises in the east. The moon sets in the west. Because it is the rise it is not truly rising. It is only the apparent motion of the earth, apparent motion of rising and setting. It is the rotation of the earth that makes the illusion that the moon rises in the east exactly like the sun. Okay. You have seen it. Here's the problem. This is our science. Our science is not based on observation but classroom learning. If moon and the sun, nobody can hide from you. It's there out in the sky. If you went out a few days and saw where the moon was rising, you would say it rises in the east. Just wait for Purnami and see it. Okay. Here is the even more tricky question. When does the moon rise?
Evening.
It rises in the evening.
Yes, sir.
And then sets when?
In the morning.
So you will be able to see it only in the sky is dark, no?
Yes, sir.
Have you ever seen the moon in the daytime?
Yes.
Yes, sir.
Yes, we have seen in the
Sir.
morning time.
So if
Yes,
the moon
sir.
is, you can see the moon in the daytime, how can it rise in the evening?
आप confuse कर रहे हो.
I don't know Hindi, sorry, but I'm not confusing. Oh, yeah, of course. Okay, let me answer. The moon rises at sunset on Purnami, which is the full moon night. Then it rises 50 minutes later each subsequent day until on Amavasya or new moon night, it rises with the sun, just in front of the sun. And again, it will rise 50 minutes later each day. So what happens is that you will see it in the night sky between in that paksham, that fortnight, you will see it in the daytime. Whereas in the after Purnami, you will see it in the night time. And it said, this is, we know this, we use this very regularly. That is called Tithi. Moonrise to moonrise is lunar day. What we call Tithi. Every Panchangam has it. You use it for all our functions, festivals. Sunrise to sunrise is solar day, Dinaha or Divasa, right? Din, that's what we call it.
Yes, sir.
Moonrise to moonrise is Tithi. And starrise to starrise is what we call Nakshatram. Ashwini, Bharani and all that, right? There's actually it's a lunisolar phenomena. The star rise to star rise is slightly more complicated. It's not really star rise. Stars also rise in the east and set in the west, but you can see other stars have risen before east to west and set in the daytime. Okay, so they're all rising and setting. Here's the problem. We know everything about galaxies. We know about the gravitational waves. We know about quasars and pulsars and black holes. We know about heliocentric theory. We know comets, the moons of Jupiter. We know all of this, and we don't know when the moon rises and when the moon sets. We know very, very advanced astronomy in several aspects. We know what a binary star is. We know all the spectral rays of the different stars. We know what they are composed of. We know about nuclear fusion inside stars. Simple observation: when does the moon rise? Where does the moon rise? We don't know. Something fundamentally wrong here, right? This is a global problem. It's a national problem, especially for us because we have this. The rest of the world doesn't use Tithi, lunar rise. We do, and we don't know anything about it. For example, suppose March 10th the moon rises at 6:30 in the evening. Then March 11th, Prathama, it will rise at 7:20. 12th, it will rise at 8:10. So 50 minutes later each day. These are only approximate times, not exact times, but you get the point, right? So from 15 days later, it will rise at 6:30 a.m. assuming that sunrise. So this is, so if you know what is therefore visible from this, a Tithi. This is a Tithi, right? And the Tithi is predictable. So if you know when the moon rises on Purnami, you can predict when the moon will rise the next fortnight, not only next fortnight, rest of its life. For the next century, you can predict, right? Every day, you just have to adjust the clock. 50 minutes later, you can tell when it's going to rise. So Tithi is predictable. What is the opposite of a Tithi? What is opposite of predictable?
Predictable.
Unpredictable. What is the opposite of Tithi? Opposite of Bhaya is Abhaya.
Atithi.
Right. Atithi, right? What is unpredictable? What does Atithi mean?
Predictable.
Guest.
Guest.
Right?
Yes.
So Sanskrit word for a guest is an astronomical pun. The fellow is unpredictable. You don't know when he'll come. The Tithi, on the other hand, is predictable. Look at the beauty of the language. All right. So just a little wordplay there. So there's an entire Sanskrit vocabulary for astronomy because we have been doing this for centuries. There is a word for sky and for space. Nabha, ba is sky, nabha is space. Bhuvyasa for earth diameter, not just Bhumadhya Rekha. The Meru really meant North Pole, Odavamukha meant South Pole, Kakshaya for orbit, Vishuvat for equator, Apamandala for ecliptic. That is the angle, the orbital, solar orbital plane of the planets. That is called Apamandala. Vikshepa, celestial latitude, declination, all these things we have words for. In mathematics, not just the Tribuja and all that, right? Parshva, Buddha, length, perpendicular, hypotenuse, plane, triangle, circle. Almost none of this we read. I think some Hindi medium students may read some of this, but most of the this are not. We are only learning Greek words or Latin words and occasionally Arabic words. We're not exposed. There's a rich vocabulary of 1,000, 2,000 years of science and Sanskrit, which we think of only as a religious language or a literary language, because we only think of it as a language of prayer and Vedas, or of literature like Kalidasa and Bharavi and poets like that, Dandi and poets like that, right? Which is sad. There is a huge heritage of science in Sanskrit. We know only a little bit about Ayurveda, but there is all kinds of other sciences. In fact, the earth, which was considered a flat surface long back, was recognized as a sphere by Aryabhata's time. And in fact, this is something from Varaha Mihira's Pancha Siddhantika. He says, Pancha Mahabhuta Ayas. At that point, he still didn't know modern chemistry. So the 5 elements were earth, water, fire, wind and sky, right? That was the fun. But he says, of those composed of 5 elements, among the cage of stars, look at what a beautiful poem, what a beautiful metaphor he gives. Among the cage of stars, like an iron cage, like a bird cage, stands the earth as a globe. Mahi Golaha. The word concept clearly understood as a globe, like a ball of iron suspended between magnets. Ke ayas kanta antaha sto loha iva, like between loha, in between metal ball between magnets. He says this is what it looked like. So this is a description. So this is the astronomical understanding of the earth as a sphere. But in art and other things, we still depicted the earth as Bhudevi. This is Varaha, Vishnu as Varaha, rescuing Bhudevi from an Asura. Here it is not depicted as a globe. Today in modern calendars and pictures, you will see Varaha rescuing the globe. But in ancient science, the ancient art was only depicted as a lady. Bhudevi was depicted as a lady. Don't confuse that astronomical understanding with the mythological and metaphorical understanding. That is a different thing, artistic depiction. We had something called the Ujjain meridian. The line passing from North Pole to South Pole via Ujjain was the meridian that was used as the zero meridian for India. We all know about this. I'll talk about tomorrow because my lecture tomorrow is about Ujjain meridian. And the equator line was well known. And the point where the equator intersected the Ujjain meridian was called Lanka. This Lanka is not to be confused with Sri Lanka. Sri Lanka is a little east and southeast of India. This Lanka point is 0 degrees longitude, 0 degrees latitude, which is slightly west of Kanyakumari, southwest of Kanyakumari. Okay. So I will talk about this in detail tomorrow. And this way they use for calculating longitude, time setting, and all that. In fact, Aryabhatta, Varamira, others said, when it is sunrise in Lanka, and they meant this Lanka, not Sri Lanka. When it is sunrise in Lanka, it is sunset in Siddhapura. They didn't know about Americas, but some point on the other side of the earth, they called it Siddhapura. They may have where the Siddhapura comes from, we don't know. So sunrise in Lanka is sunset in Siddhapura. Noon at Yavakoti, a point east of Japan, right? Somewhere here, it is noon. And midnight in Romakavishya, 6 hours behind us. So that was their understanding of meridians. And we used the Ujjain meridian as the zero meridian. This meridian has been in use for around at least 1,500 years, probably longer. We'll discuss that tomorrow. Okay. What did Aryabhatta contribute to India? Not just zero, which he didn't invent, which already existed before him, but algorithm for square roots. for cube roots. He was the first one to give a methodical procedure to calculate square root of a number. Methodical procedure to calculate cube root of a number. He gave formula for sum of a series 1, 2, 3, n. Then gave a sum of a series of squares 1 squared plus 2 squared plus 3 squared. He already knew the way to calculate root of a quadratic equation because he implies that in this particular thing. And sum of a series of cubes 1 cube, 2 cube. Solutions for linear indeterminate equations. You have an equation like ax plus by equal to c. Aryabhatta had a solution for it. And he gave a formula for sine, trigonometric sine. I'll give you a sample here. You take a circle like this and you put a chord. You know this, right? This is a circle, this is a chord. And a segment of this we called arc, and this is a chord. Now this looks like a bow and is bowstring, doesn't it? And so that is exactly what is the word used for arc of a circle. It was called chapa or danush, which is the word for bow. The arc was called chapa, and this line, the chord, was called ja, which is the Sanskrit word for bowstring. So what does this have to do with sine? If you take a circle like this, draw a chord, couple of radiuses, and intersect it with a chord, you now have two radiuses and you have this chord, and this is what it is. A sine is this chord opposite of this angle divided by the radius. That is the triangle interpretation is this. For a right angle triangle, opposite divided by hypotenuse. This radius here is the hypotenuse of this right triangle. That we know as the sine, right? Opposite by hypotenuse. The Indian understanding was of half the chord divided by this radius. This is the chord ja. This part of divided by this radius into two halves is the half chord or the ardha ja. So ardha ja was called either ardha ja or ja, and that was used as the measure for. I'm not going to explain in detail, but this ja went to Arabia, Baghdad, along with the rest of the mathematics, Aryabhatta's mathematics, with zero and all that. From there, it was called jab. It got mispronounced as jab, which is a Arabic word for pocket, right? Like a pocket. This got translated into Latin as sinus and truncated into English as sine. And today, we learn the sine rather than the ja from which the sine originated. The trigonometric sine that we are learning today goes from Aryabhatta to Baghdad to Europe to England and then comes back to us as sine, and this is what we are studying today. Another irony. Okay. Aryabhatta explained a lot of mathematics. I'm just giving you kind of an overview of some of these mathematical aspects. But Brahmagupta was the first person to introduce the arithmetic of zero. He was the one who talked about negative numbers in detail. Some basic concept of negative number was known, zero was already known. But Brahmagupta was the one who really explored and explained this concept to us. For unknowns, the word used was avyakta, and in fact, different words were used at different times. For what we call X, Y, Z, the word they used was not the letters of the alphabet, they used avyakta. The word avyakta means an unknown. And for equation, the word was sama or samakarana. They had a concept of equation, even though they hadn't used the arithmetic symbols like plus, minus, and all that, which came, as we saw, only in Europe in 16th century to 17th century. In fact, this is what Brahmagupta talks about: zero addition, zero negation, and so on. For positive number, he uses the word dhanam. Dhanam is what? Wealth or profit. So he uses a mercantile term, a business term for positive number. And he uses the word rinam for a negative number. Rinam is what? Debt or loss, right? Comes from business concept. And he uses the word shunyam or kam. Ka is sky. Sky is the Bhuta Sankhya word for zero. So both are used, shunyam or kam, and there are like 30 words for the zero in Sanskrit. And it is either of them. He uses kam and shunyam. And he says, dhanayoho dhanam, rinam rinayoho. So that is, if two positives are added, you get a positive number. Two negatives are added, you get a negative number. Dhanam rinayoho antaram sama aikyam kam. So what happens when a positive and a negative number are added? He says, if they are equal, sama aikyam, if the dhanam and the rinam are equal, the addition gives you a zero. Rinam aikyam cha dhanam, and then so on. So you know the basic concept. So he talks about addition and subtraction of positive numbers, addition of zero, positive, if you add a zero to a positive number or a zero to a negative number or zero to zero, If a zero to positive number or negative number, it stays positive number or negative number. If you add 0 to 0, you get a 0. That is what he said. So dhanam plus shunyam is dhanam, ranam plus shunyam is ranam, and shunyam plus shunyam is shunyam. He gives this simple arithmetic. Somebody had to state it, right? Brahmagupta states this. In fact, he also goes on to state things for multiplication. But since this is a brief talk, I won't go into it. Okay, and others also have stated it afterwards. In fact, Brahmagupta gives very interesting. This is a different words used in different periods for unknown quantities. The modern English notation, of course, variable or XYZ. The Jaina mathematicians called it Yavat Tavat, whichever, that ever. That is what it meant in around 300 BC. Aryabhatta uses the word Ishta or Icha, desirable number. Brahmagupta uses the word Avyakta. And Bhaskaracharya in 12th century uses the word Bija, which is why we have Bija Ganita or algebra, unknown number, right? Brahmagupta says this: Avyakta Varga Ghana Varga Varga Panchagata Shadgata Adinam Tulyanam Sankalitam Vavyakalite Pritut Tulyanam. So what is he talking about? He's saying when you are adding squares, cubes, so Avyakta is unknown. So power in the variable with the first power. Varga is square. Ghana is cube. Varga Varga is square of a square, so it's a fourth power. Panchagata is fifth power. Shadgata is sixth power. Adinam. And in the same sequence, when you are adding coefficients of different powers, x squared, x cubed, x power 4, x power 5 and all that, you should add the coefficients of equal powers. That is what the second line says. Unknown equal values, addition or subtraction of correspondingly. Pritut tulyanam. So whether you are adding or subtracting, tulyanam here is the word for coefficient of a particular power. So the word applies to each of these particular terms. So he's talking about how you add this. You add equivalent powers. So Brahmagupta's equation format is like this. Suppose you had an equation like 5x squared minus 10x minus 8. Remember, they didn't have x, all that. So he would describe it as Yavat Vargam. That is square. Yavat Vargam is square. So square of that is 5. Yavat is that number. So coefficient of the linear term. And constant was called Rupam. So constant here is 8. Right? And the other one is Yavat Vargam. This one is 7 x squared. So the coefficient is 7. Here there is no linear term at all. No x coefficient. So he puts that as 0. Yavat is 0. And the Rupam is 22. So he puts 22. But this 8 is negative and it is marked with a dot on top. So this is the way the equations were represented in Sanskrit for actual calculation in Brahmagupta's time. And he learned this from a commentary by Pritudaka Swami. This is how they did this. I am writing it in English, but they used naturally Sanskrit letters and words to describe an equation. Brahmagupta gave us equations: square of unknown, square of this thing, the dot over. That is the representational format. I want to share a poem with you. This poem is from a person who lived another couple of hundred years later, around 850, 855, something like that. A person called Mahavira. This is a poem, and I'll read it out and then let me explain the meaning. Laukike Vaidike Vapi Tata Samajike Yah Vyaparastatra Sarvatra Sankhyanam Upayujyate Kamatantre Artatantre Cha Gandharve Natake Piva Supashastre Tatha Vaidye Vastu Vidyadi Vastushu Chando Alankara Kavyeshu Tarkavya Karanadishu Kala Guneshu Sarveshu Prastutam Ganitam Param. These 3 stanzas. What does it mean? Laukika, that is Laukikam. In Laukika, all this A means in that. So in daily life. Vaidika is Vedika. Religion. Vyapara, Sarvatra. Vyapara is trade. Sarvatra means everything. Sankhyanam Upayujyate. Mathematics is useful. In daily life, in learning, in religion, in trade, in every field, mathematics is useful. Kamatantre, Arthatantre cha. In the art of love or in the art of wealth, economics basically, right? Gandharva is music. Nataka is drama, dance drama. Natake piva. Supashastra, cooking. Vaidya is medicine. Vastu vidyadi vastushu, in construction, architecture, all that, right? Chandaha, Alankara, Kavya, poetic meter, all the things that you need for even in poetry and meter. In fact, the first reference to the number 0 comes in Chanda Shastra. There is a sloka called Rupe Shunyam. That is where it comes. So Chando Alankara Kavyeshu Tarka Vyakarana. Tarka is logic, arguments. Vyakarana is grammar. Kala Guneshu Sarveshu, even in several aspects of the arts, Prastutam Ganitam Param, mathematics reigns supreme. His name is Mahavira. Beautiful, no? We have a national anthem. In every textbook in school or college, we have this, Janagana Mana of Rabindranath Tagore. This anthem should be there. This is an anthem of mathematics written in Sanskrit by a Jain mathematician. He's not a Hindu mathematician. He's not following Vedic this thing. So Jain mathematician has written this beautiful poem. I think it should be there, but I just wanted to show you this particular poem, right? Okay. So we talked about zero, we talked about astronomy, we talked about poetry in mathematics. Let's look at infinity, because the title of the talk was zero, men who knew zero and infinity. Bhaskara in his Siddhanta Shiromani explores the arithmetic of infinity. He doesn't use the word anantam for infinity, which was the Vedic concept, but he calls it ka hara. Ka is zero, hara is division. So zero division, number divided by zero, he calls it ka hara. So we have look at what a beautiful division of beautiful representation for the numbers. Look at the word used for it. This again, like Tribhuja or Samadala Koti, you've probably not heard of. I didn't know about this 3-4 years back. So I am sharing things with you that are also surprised me, delighted me, and all that. So this is what Bhaskara uses. Follow that by Madhava, who not only gave a formula for dimensions of infinity, the concept of infinity. You also have an infinite series. You have something like a sum of an infinite series, right? Madhava, in the 8th century, a person called Veerasena came up with a formula for one specific infinite series. He said 1 by 4 plus 1 by 4 squared plus 1 by 4 cubed dot dot. Here I put 1 by 4 to the power of n, but no, he says 1 by 4 all the way, infinite powers. If you sum the infinite series of powers of 1 by 4, the sum will be 1 by 3. This is somebody is given in the 9th century, 1816, a person called Veerasena in a book called Dhavala. This is mentioned in the 14th century by a Kerala mathematician called Madhava. And Madhava's later disciple, actually disciple of a disciple called Nilakanta Somayaji, asks a question. Madhava also repeats this formula. He says, how can the entire sum of powers of a 1 by 4 add up to a finite number? There is an infinite series. How can it add up to a finite number? It should be infinite, no? How is it that the sum of a series only increases up to that limiting value? He is asking a question of limits. We study limits as calculus. We study as sum of this thing. One he asks, how is it that it increases up to that value, and does it increase until that value? So does it come to exactly 1 by 3, and does it come to only 1 by 3 when you go on into infinite number of terms? And so he actually gives a derivation. He says, take this, 1 by 3 is 1 by 4 plus 1 by 4 into 3. I'm not going to work this out, but you can work this out and you'll see it. So 1 by 3 is 1 by 4 plus 1 by 12. Simple mathematical fractions, you add it, you will get that. So what is the second term, 1 by 4 into 3, 1 by 12? You take that, you spread it. You take that, you get 1 by 4 into 4 plus 1 by 4 into 4 into 3. You can spread this as this. You check this, you will get this. Substitute this, you will get this result. So what is this term, new term that we added? 1 by 4 into 4 into 3 is 1 by 4 cube plus 1 by 4 cubed into 3. And so what will happen? You take this term, it will again expand to another higher power of 3. What is this? This is exactly what this is. Expand it. You can expand this last term infinitely and it will sum up to 1 by 3. So this is it. That is why it is coming to a... So as we add more and more terms, the difference between 1 by 3 and the power of 1 by 3 becomes extremely small, but never zero until we add up to infinity. So we have Bhaskara defining infinity, and we have Veerasena, later Madhava, Nilakanta Somayaji explaining how an infinite series adds up to a finite quantity. You actually have formula for pi, which is also an infinite series. Madhava gives that. It was later called Leibniz-Gregory series because it was considered Leibniz and Gregory, the European mathematicians, came with that formula. But today it is called Madhava-Gregory series in honor of Madhava, whom the Westerners didn't know before, but now they have known and accepted. So this is my kind of overview of some selected aspects of mathematics that is found in, and astronomy as is found in Indian texts. Nearly 80% of the school mathematics that we study, whatever, not just in India, worldwide, what the mathematics we study, 80% of the mathematics that we study, trigonometry, algebra, arithmetic, some other concepts, some of it is local, but 80% of it is Indian. But for some reason, we study all of it using Greek terms, which is really unfortunate. We should really fix that perception. Thank you for that opportunity. I hope you had a, enjoyable time. I hope you had fun learning some of these concepts. I'm part of this group called Varamira Science Forum. If you have any questions, I'll be happy to answer them. Thank you very much.
So this was really a wonderful, insight into so much of history of mathematics. And in fact, there's so many hands risen, and I really wonder whether we can take many questions or not. But at least 5 minutes at the most, I can,
Okay, I'm happy to answer as many.
Right. So, Dhanush, would you like to ask something? You have the mic. Okay.
Sir, hello.
Yes.
Yes.
So I think, yes, sir, just as you said, we should change every term from Greek origin to
Not every
Sanskrit
term,
origin.
but at least the familiar terms, some things should be introduced, right? We have no exposure. So,
Sir, I think in every field we can find this.
Right.
Every discoveries were made by the Europeans after they invaded India.
Devika, do you have something to ask, beta?
Sir, it was a very nice session. We couldn't take our eyes from the screen.
Wonderful. Thank you so much.
Very interesting and it provided us with.
Yes, Sheila ma'am, would you like to put forward a query?
Yes, ma'am. Very good afternoon, sir. It's my pleasure to thank you. I learned many things from this session. It is really very, very interesting. We are very glad to hear many new perspective. Our perspective is different, but you opened our eyes. It is a very great, immense pleasure for us to learn many things from you. This session is really mind-blowing. It's amazing, sir. Thanks a lot, sir.
Himanshu, Bhushan, would you like to ask something, Himanshu?
I think there was some person in the chat window asked some question that flew by, something about rotation.
A lot of questions and a lot of compliments too.
Yeah, I can see this. Chats are all wonderful. Thank you, amazing.
Yes, really.
So that was the intention. So almost 95% of what I told you, I didn't know 15 years back. So I also learned. So don't be ashamed of not knowing something. We should be ashamed as a society. As individuals, I don't know. So hopefully that was information. Any questions? If anybody has questions, I'll be happy to answer them.
Yes, Miss Isha. There are so many children. Yes, Jeevan Siddhartha, would you like to ask something?
Yes, thank you, ma'am. I'm Jeevan Siddhartha from Kolpatti, from National Engineering College, Tamil Nadu.
Oh, Tamil Nadu, very good. Hello.
I am to know that one of our Indian languages has inspired the world in so many ways. My question is that, do you think that the influence of India in our country the influence of English in our country is so much that it deprived all other languages so that it underestimated Sanskrit words?
No. We can't think. It's a positive something. We can't think that way. We can't. Let's not. Here's the thing. Let us not belittle English simply because there are wonderful things that we don't know about in Sanskrit. English has contributed enormously from Newton to other mathematicians in English. See here, let me put it this way. Whose fault is that?
Our fault.
So let's not blame English here. England ruled us for several years, but we are independent for 70 years. We're still blaming England. That's not fair. In 1947, you blame England, it's okay. In 2020, it's not fair.
Yes, sir. We'll make sure that we'll learn more of this in our upcoming years.
That is. I think that's the purpose of this whole series is like that, and the purpose of my lecture is also to just open your eyes to what is there. So from there, what you do from there is up to you. I
So
will
one of the
share my
students,
link on this here.
so one of the
Context of
students,
astronomy
Bharat
says
Raman,
that
says,
you can see.
if it was not discovered by Aryabhatta, then how is it so famous for him?
I'm sorry?
One of the child has written in the chat box, if
Okay.
zero is not discovered by Aryabhatta, then how it is famous for him in his name?
Because the only name we know. Can you name any mathematician in India before Aryabhatta? Aryabhatta is famous. When ISRO launched the first satellite, we called it Aryabhatta in honor. Aryabhatta was very important because he started off what is called the classical era of modern mathematics in India in the 5th century. But we had a tradition of mathematics long before that. The problem is most of the books before that are lost. Unfortunately, a number of books written before Aryabhatta. There are 18 famous Siddhantas called Surya Siddhanta, Lagada Siddhanta, all kinds of Siddhantas. Only one book from the earlier period, one or two books, sections of books from the earlier periods survived. There was an astronomer called Lagada, who's really our first astronomer. He wrote a book called Vedanga, Rigvedanga Jyotisha, Yajurvedanga Jyotisha, both are attributed to him. It is calculated that his period was 1200 BC. 1700 years before Aryabhatta. How many have heard of him? Lagada is an astronomer who lived 1700 years before Aryabhatta and nobody knows about him. Most people don't know about him. People in Sanskrit, Sanskrit graduates don't know about him. Mathematicians don't know. So what I told you, some of the information that I'm presenting it to you, 99% of engineers don't know, 99% of mathematicians in India don't know, 99% of astronomers don't know. So that is a very sad situation. So just like that, Aryabhatta also, people, misattribute zero to him because that is something that, people just said, they don't know what he actually did and zero is attributed to him. It's like heliocentric theory or gravity. They didn't invent, but it is misattributed to him. But we don't even know when the moon rises. So we have very fundamental problems here. So like that, we don't know. The general public, we don't know. Sadly, that what Aryabhatta did. Square root, cube root is his contribution, major contribution. We don't know that, but we think zero, and zero is much older than it.
That was an absolutely, of course, very enriching session, and definitely we'll be hearing you tomorrow as well, if I'm not mistaken. Yes, we have your session tomorrow, sir. So, of course, with these words, I think we need to really thank sir. And of course, dear children, I think you can get in touch with sir and further enhance your knowledge and learning. Okay. So with these words, I thank you so much, our Gupta sir, and we'll be looking forward for furthermore sessions with you. And as I can see that the children on YouTube as well as on the Zoom platform, they are really thankful to you for all the insights you have given. Thank you so much. Of course, with these words, I'll introduce the children to the next session as well. Thank you for such an enriching session, Gopi sir. And Manisha Di,
yes.